In this video, we're going to look at an example of finding unit tangent vector, unit normal vector, and curvature of a function in terms of t. So we're given the vector valued function t squared sine t minus t cosine t and cosine t plus t sine t. We're asked to find the unit normal vector, the unit tangent vector, the unit normal vector, and the curvature, all in terms of an arbitrary t. Well, the first step to this is taking the derivative. So we notice that the derivative, after some simplifying, for the vector valued function is 2t, t sine t, and t cosine t. We need to make this into a unit vector to find the unit tangent vector. So we'll do 1 over the magnitude times the derivative. Playing around with the magnitude here, we notice that we get a t squared sine squared t and a t squared cosine squared t. That just simplifies to t squared, so we end up with a 5t squared under the radical. Well, square root of t squared will give us just t. Technically, it gives us absolute value of t, but here we'll just assume that we've got positive t's that are going in, just to simplify the notation. If we have positive t's here that's going in, we can cancel the t's in each of the components, and we end up with 1 root 5 times this vector 2 sine t cosine t. To find the unit normal vector, we'll take the derivative of the unit tangent vector. We get 1 over root 5 times the vector 0 cosine t negative sine t. So to find the unit normal, I need to take that the derivative and divide it by its magnitude. Well, we notice that this piece, without the 1 over root 5, the 0 cosine t negative sine t actually has a magnitude of 1. If we divide by 1 over root 5 and multiply by 1 over root 5, I need to divide by it because it needs to be there for the magnitude piece. The 1 over root 5's cancel, and we just get 0 cosine t negative sine t for the unit normal. Finally, we have all we need for figuring out the curvature. Curvature, one of the ways to compute curvature is the magnitude of the derivative of the unit tangent vector over the magnitude of the derivative. Well, earlier we calculated the magnitude of the derivative. It's right here. That's 1 over root 5 times t, assuming again that we have t's that are positive. I didn't want to make it messy with absolute values stuck everywhere. So that's why I've got 1 divided by root 5t here in the denominator. We also computed what the magnitude of t prime of t would be. Again, this piece here has magnitude 1. So the magnitude of t prime would be 1 over root 5. So again, your 1 over root 5s would cancel, and you would get 1 over t as the curvature of this curve.